Hello, Martin Warwick here. We're at the Small Cells World Summit 2014 in Excel in London's Docklands, and I'm talking with Andy Sutton, who is the Principal Network Architect at EE. What factors are driving demand for small cell technology in mobile networks right now?
Okay, there are several small cell use cases which are quite key at the moment. The most established to date is femtocell, so typically residential femtocell to enhance in building coverage. But nowadays when we talk about small cells, we tend to be talking about public access picocells, which are either deployed for coverage, so certain kind of rural use cases, but increasingly now we're talking about urban infill to supplement capacity into our network to provide capability to support demand and growing data demand.
So that's what's driving the market at the moment and where the opportunities are. Let's look on the obverse of the coin. What do you think are the key challenges, the problems that are being faced by telcos as they begin to deploy and implement small cell solutions?
The key thing is finding the right total cost of ownership model. There's so many parties involved in deploying small cells, from the operator who delivers a spectrum, the vendors who provide the equipment and the backhaul as well as the radio access itself, but also you need the physical structure. So be that a lamppost, for example. So there's lots of issues around acquisition of lampposts and then the physical installation on these structures as well, and actually managing that whole process. It's very different to acquiring a traditional rooftop or field for a macro cell to very, very different environment. So lots of other parties involved, so quite complex at the moment. And I think that ecosystem is still developing and maturing, so it's very early days at the moment.
Do you think small cell technology is actually capable of delivering telco requirements now, as of this moment, or does the technology need more development?
It's come on a lot in the last few years. I think we've gone through the usual kind of hype cycle, etc. with small cells. I think nowadays we're at the stage where we're starting to see maybe second generation of equipments that have the features we need. Since standardization of release 10 from 3GPP, we have all the necessary features to support the implementation of small cells in a HetNets environment, and that HetNet's absolutely critical. It's not just about small cells, it's about small cells interacting and working cooperatively with a macro cellular network in the future on the same frequency band as well. So we have a lot of the tools now available to make that happen. There's still some question over interoperability between different vendors, so it's very likely early implementations will be the same vendor in the macro cell and small cell layer. Clearly as operators we're very, very keen on multi-vendor interoperability, so it's something we'd like to see develop further. But in terms of basic service, yes, the capabilities there, the standards there, and the equipment's available.
And how does small cells for 4G and beyond fit in with the move towards NFV, Network Functions Virtualization?
Well, a lot of the small cells today are complete radio units effectively, so we have baseband and the radio units in the same module, so a distributed RAN approach effectively. When we talk about virtualization, I guess in the wider context, we're potentially talking about a move towards maybe cloud RAN environments where we have a centralized virtualized baseband capability and small cells, macro cells extended via front haul. So that's an evolution, but actually it's only one of a number of evolutions we're likely to see in the kind of midterm really. The evolution of distributed RAN is perfectly valid. I think we'll see more and more capability in the traditional kind of network topology, so that's going to be quite important as well. In terms of virtualization, a lot of that will happen more towards the baseband and certainly more in the core of the network in the early days. I think it'll be a little while before we see software-defined radio, virtualized radio at the edge of the network, but it's certainly the start of a cycle of development.
What role do you see for small cells beyond 4G and into future 5G networks?
Well, as we move through the evolution of LTE and LTE Advanced, we'll see ever denser networks of small cells, more and more capability. They'll start to carry more and more traffic from our networks. So therefore, we'll see 2600 megahertz band, with 3500 in the future as well, deployed as small cells. So we'll start to take more traffic in that layer. Over time, as we introduce 5G, we're talking about ultra-dense networks, so even more small cells, ever higher frequency bands. It's very likely we'll see 1 or 2 millimeter wave bands introduced, so again, very dense networks. At such a point, the small cell really will be the true workhorse of the cellular network. The bulk of the traffic will then go through that small cell network. We're very likely to see a separation of control and user plane where the macro cell itself starts to become a kind of control plane that also provides some user plane capacity, but actually the real bulk of the capacity is managed through that small cell layer.
How are telcos leveraging their existing backhaul capabilities?
In terms of the macro network today, we're deploying significant capacity now, so we're typically deploying gigabit Ethernet into our cell sites. So it's a huge shift from where we were just some years ago when we were counting backhaul in E1s in 2 megabit circuits, of course. So we're now delivering gigabit Ethernet capacity to support multiple radio access technologies, 2G, 3G, 4G. And in many cases, of course, cell sites are now shared. So you've got multiple operators sharing that backhaul as well. So we're implementing various techniques to effectively virtualize the capability on top of that backhaul network as well.
We're seeing this massive increase in data traffic globally. What new solutions are being introduced to cope with that?
Well, certainly the move towards gigabit Ethernet delivered over fibre, but also gigabit Ethernet delivered over point-to-point microwave radio has been a key evolution of our own network. So we've moved from low capacity radio, maybe running at some tens or hundreds of megabits per second, up to very high capacity radio systems running at 400-500 megabits per second, and then introducing cross-polarization interference cancellation techniques as well. So we're now running between 800 megabits per second and 1 gigabit per second over cross-pole 56 megahertz channels. So again, significant capacity on the microwave radio, and that's required a real evolution in the technology in that space to support the extension of the fibre-based connectivity over the wireless link.
And how can backhaul be used to increase speed and reliability to wireless customers?
It's about obviously increasing the capacity of the backhaul network, but also reducing the latency, making the backhaul more deterministic. So we're minimising latency, we're trying to remove any kind of packet delay variation, any packet error loss rate, such that actually the upper layers, the protocol layers, the application layer for example, is very, very efficient. We do very limited retransmissions in the network, and therefore we deliver the optimal quality of experience through improved backhaul. In terms of reliability, as we evolve our network, we're looking at introducing more kind of ring architectures. We can introduce protection on microwave radios, so we have equipment redundancy, for example. So there's a whole range of techniques that we can deliver, that we can implement to deliver more efficient backhaul and more reliable backhaul.
What do you think are the specific backhaul needs of small cells, and do you think that Wi-Fi can ever be a practical solution?
Okay, small cells really need high quality backhaul. The key thing is to make sure the user quality of experience is consistent. The user doesn't want to think, I'm on a small cell, I can tell from the experience I'm getting. They have to be invisible. Macro cells, micro cells, pico cells, completely invisible to the user. So the user gets the best connection, the most appropriate connection, and always sufficient rate for the service they want to interact with. So therefore, we need to deliver backhaul that's got capacity, low latency, the same kind of parameters we would consider in the macro space as well. So therefore, it's going to be a range of fibre optic based services, but also a wide range of wireless solutions, from point-to-point solutions in the millimetre wave bands. The likelihood is we're going to use multi-point radio systems down in the small cell network as well, and certainly opportunities for some non-line of sight backhaul. However, the use of Wi-Fi in that kind of 5 gigahertz band as backhaul, I think is challenging. There's no guarantees as to performance. I think moving forward we'll see an increased proliferation of that band for end user devices anyway, which will increase the noise level and the interference. So therefore, I think with lots of work to do, we've got lots of tools available that help us to build that small cell backhaul solution, but we do need to guarantee quality of experience.
Andy Sutton, thank you very much.
Thank you.